Hello students, we are going to describe today about ray optics where a spherical mirror formula is required. The spherical mirror formula in case of in case of a concave mirror. The formula is 1 by f is equal to 1 by u plus 1 by v. Now we have to prove this. How to derive this formula? We will go through the ray diagram required to prove this formula. So first of all, we will take a concave mirror. So we first draw the diagram for concave mirror. We first make a concave mirror by giving shadow to the one side. To decide it as a concave, painted surface is given to the bulge side to make it as a concave reflecting surface to the left side of decided areas. We have got the concave mirror. We first decide the point for the pole P, and then we draw the line. We draw the line for principal axis. Yes, we have taken a principal axis, and so this principal axis has been drawn, which is passing through the point P. P is the pole, and we just choose the point for the object, and in the case of, we will write for the point, one point for focus, another point for center of curvature, which is visible, and we put the object just beyond C. Yes, we have taken object, we have given the name AV, the size of the object, which is placed just beyond C. The ray of light will travel from A point. So we will draw the ray from starting from point A to the mirror. So it will start from here. So the ray of light is starting from A. The ray is starting from A, and the arrow should be given there. So ray of light is starting from A point. It goes to the D point. We have given the name D, where the light incident. So arrow sign given over it. The ray, when incident on the point D, it gets deflected back from this very point, and it will returns back after reflection passing to the point F. So we just draw the line passing through point F and this very point for the focus. So one ray starting from A, incident at the point D, then gets reflected passing to the focus, and another ray will pass through the center of curvature of the mirror. So we first put the at the tip of the object and we just start to draw the straight line should be there. It goes directly to the mirror at any new point. We may take here as D dash and it once bounces back, retraces the path and there is actual intersections of the two rays, one coming through the focus and other coming from the center of curvature and then returning back, retracing to intersect it at any one point which lies between C and F. So we get the inverted image A dash B dash in between C and F. Now this is the situation of reflection of light through the concave mirror and with the help of such diagram we will prove how 1 upon F is related to the 1 upon U added to 1 upon F. The starting point we will decide from pole of the mirror to, yes, we will write here P stand for pole, we should bear in mind. And from the pole is such a point from where all the distances are measured. So by keeping in mind the location of the object, which is AB at B point, we just trace it for the location of the object from the pole of the mirror. And this very distance of the point B is taken as U. So we will write the value of the object distance P to B. We will write minus sign here with the sign conventions because object is placed in front of the mirror. So negative sign is placed by writing for the value of PB minus. Similarly, the final image is formed at A dash B dash. B dash is the location from P to B dash. We will write for image distance. Measure from the pole. And we will write here pole to image distance PB dash as minus V. Negative sign also comes in the sense of sign conventions because image is formed in front of the mirror also. So we have written here minus U for object distance and minus V for image distance. Now center of curvature is also located here. From the point P, the center of curvature is written as capital R and we will locate it as P to C. P to C is written as minus R side according to sign convention. And focal length is small f, the distance of the principal focus of the concave mirror from the pole. So we will write here P to F as minus 8, which is focal length. So all the position of object as well as position of image, position of focus from the pole and position of center of curvature from the pole has been selected here according to the sign convention. AB is the object and A dash B dash gives the meaning for image of the object. Image of the object. Now the another line which must be joined from the center of curvature to the point of incidence. We will draw the lines as a normal C to D. C to D is the point. This very dotted lines act as normal to the point D. So we are writing an CDN. CDN. This is the normal. This very normal will decide the angle of incidence made at the D and angle of reflection at the same point D. One perpendicular must be drawn which falls near to the pole from the point of incidence D. This very perpendicular on the principal axis DM, M is the point very near to the pole. So DM is drawn perpendicular on the principal axis BP, and this very M point is very close to P point, approximately near to the pole. So M is very near to the pole. All the distances from the pole coincide the distance from the M also. Now how to decide the image distance and object distance? To decide the image distance and object distance, we will take the two triangles. One making the position of B dash, A dash, B dash with respect to the point F, A dash, B dash, F and D, M, F. So we will take these two triangles. How to see this? Next page. In triangle, the triangle is here, A dash, B dash and F. And another triangle which is similar, D, M, F. So we get such triangles where the image is formed and this very M point, A dash to D, F is the point. These two triangles are similar. A dash B dash F is similar to the triangle DMF, and its similarity is there. So height A dash B dash to the height of the object, which is equal to the height dm. So height to height and base B dash A, base of one triangle is equal to base of the other, MF. So these two sides are in the ratio. Sides are ratio of the two sides are equal for similar triangles, and because M point is very close to the P point, we will write here A dash B dash, which is the size of the image. dm is equal to d2m is equal to size of the object. So we will write here AB. So we get here B dash F, and B dash F is here distance measured from P to B dash minus P to F. So how to write the B dash F? B dash F will be written in terms of pole to B dash minus pole to F. This will give the value of the distance B dash F. And MF, M is very near to pole. So we will write P and we will join with the F. So we get here some relation. What is the value of PV dash? PV dash is equal to minus V and PF is equal to minus F, focal length. So directly we will put here minus V with the minus F and then minus F. So that we can write minus V plus F divided by minus F. And by arranging the sign, we get V minus F by F. This is taken as equation 1. So after comparing the size of the image from the size of the object, we get the relation for between V, F and F. This is the one way to get the values. Similarly, we will choose another triangle relating to the image distance with the center of curvature. In triangle A dash, B dash with the center of curvature and one triangle relating the object distance AB with the same center of curvature of the mirror. These two triangles which relating the object distance and image distance A, B and yes, A dash, B dash and considering from the center of curvature of the mirror. Automatically, no doubt, A dash B dash C is similar to the triangle ABC. And due to similarity, we can easily write for the height of the image to the height of the object. So A dash B dash image height to the ratio of the size of the object AB is equal to the B dash C, B dash C and BC. How to dash the B dash C? B dash C is measured from the pole of the mirror. The pole is P and the distance of the point B dash and C. So pole to center of curvature, pole to center of curvature minus pole to the point of the image. B dash. So by taking the difference of the two, we can write B dash C. And how to decide the value of the BC? B is the point of object distance and measure from the pole. So pole to B minus pole to C. So pole to the point of object PB minus pole to center of curvature of the mirror. This will give the value of BC. Now we will put the values of PC and PV dash. What is the value of PC? Pole to C is the radius of curvature capital R because of concave mirror minus sign must be taken and pole to image distance is minus V with the negative sign. Pole to B is the position of object and pole to C is minus R. So we know that F is equal to R by 2. So we can write in place of R as 2F. R must be equal to 2F. So directly we can put PC value as minus 2F with the PV dash for minus V divided by PV minus U with the PC minus 2F. And so A dash, B dash, size of the image to the size of the object becomes equal to minus 2F plus V with the minus U plus 2F. And these two terms This is taken as equation 2, and with the help of equation 1 and 2, we will write for one equation A dash B dash by AB, which is V minus F by F. We will put the value of by using equation 1 and 2. We can write for, we get for V minus V plus H. Equation 1. Equation 1 is the, yes, V minus F by R. V minus F by R becomes equal to minus 2F plus G divided by minus U plus 2F. And with the help of this, we will write for the equation V minus F multiplied with the U plus 2F and minus 2F plus V multiplied with the F. And simplifying this, writing for minus U into V, then 2VR, then minus minus plus U into F, minus 2F squared. This is written for to the left hand side, and right hand side minus 2F squared plus V into F. Now we will write for all the terms minus 2F squared to the right hand side and minus 2F squared given to the left hand side. We cancel out each other, and then Vf twice the Vf, and this very Vf taken to the left hand side, and U into F, U into V. So we rearranging this, writing for Vf plus U into F is equal to U into V. This very term we can write by dividing all this term if you are taking equation 3, and dividing this equation 3 by all three terms U into V into F. So V into F divided by U into V into F plus U into F divided by U into V into F, U into V divided by E into V into F. By dividing all the terms, we get VF cancel out, UF cancel out, UV cancel out, and we get the relation for 1 by U added to 1 by V equal to 1 by F, and we get the required mirror formula. So this is the way to get mathematically how to derive the mirror formula in the case of concave mirror.